Welcome back. In this particular session, we'll be talking about selection sort. So, selection sort, as the name itself is giving, that we need to actually select either the minimum or the maximum value, right? So, it is also a sorting techniques which follows the brute force. So, we already have seen one particular, sorting algorithm, which is bubble sort, also based on the brute force. And I told you brute force is something where we used to see all the possible cases. So I gave an example in a bubble sort session, like we have a bunch of keys and a lock, right? So here also, like bubble sort, selection sort also do the comparison. So the adjacent elements are compared, okay, but we don't do the swapping. Like in a bubble sort, what we exactly do is that if you have one element here, one number, another, we compare both, right? If this number is greater or less than, based on whether we are going for ascending or descending, we do the swapping. But here in selection sort, we don't do the swapping in each of pass. What we do is that we find out the position where the maximum or the minimum element is. So suppose we have 23 and 35. So 23 in position 1, 35 in position 2. So 35 is greater. So now I will say, first initially I will say position is 1, maximum value, okay. Then when I compare, I see no, the position 2 value is greater. So I will put position 2. Like that, I will scan all the elements, okay, right. And then I will find out the largest or the smallest element along with the position. Then based on the position, after the completion of one particular pass, we will going to swap the elements, okay, right. And like bubble sort, it is also one of the simplest sorting techniques to implement. So just simple algorithm is like that: input an array to be sorted, okay, right. Here I am talking about the smallest element. Find the smallest element in the array and swap the smallest element with the first element in the array. So we are doing in ascending order, right. So what I am doing, I am finding out the smallest element, okay, and then after completion of one particular scanning of all the element, I'm swapping with the first person, and then I will going to repeat this, okay, till I have completely done the entire sorting itself, okay. So let us see an example. This same example, we have 30, 45, 2, 16, 31, 7 and 23. See, in the bubble sort, we have not mentioned the position. So I have position 1, 2, 3, 4, 5, 6, 7. Now you may have a confusion. Oh, in programming, when you do programming like C, C++, with the initial array we have 0, right? Array index start from 0, right? Okay, yes, while implementing into, but we are doing in a terms of algorithm here. So 0 doesn't have any kind of meaning. So we are saying the first element, second element, third element, like that. Okay, now I will going to compare the 30 and 45. Okay, right? I will compare the 30 and 45. Okay, yes, right. So now you see this particular thing I have considered as the J. So I will scan from here to here. Okay, right? Sorry, I. This is considered I, and this I have considered as J. Okay, right? This is the what, not J loop. So I will take this element first, and then I will start comparing here. Okay, then I will take this element, then I will start comparing from 2 to 23. Okay, then I will take the 2 element, I will start comparing from 16 to 20. That's how the thing is, and we are swapping in the first element, right? Okay, so first, okay, and this is the minimum. So I consider the first element, okay, to be the minimum. Okay, now I start comparing the next element. Okay, so that's come from the J, right? So now is it less than 30? No, right? It is less than 30? No. So what we do is that we don't do. Now 2, is it less than 30? Yes. So now my minimum is, now what will be my minimum? Minimum will be, it will be 2, and that is there in the position number 3. Okay, so now my minimum, now I will have to compare with the minimum. Yeah, the value 2. Now is 16 less than 2? No. Okay, then I start with 31. Is 31 less than 2? No. Okay, is 7 less than 2? No. Yes. Okay, then if 23 less than 2, that is also no. So I got the first element to be 2 and I've shifted from position number 3. Here if you see, this is the position number 3, the smallest element. Let us go back. Here see, we got the smallest element in the position 3. So enter scanning is done till 23. Okay, now I swap this 2. So I swapped. Okay, so I put 2 and here I have 30. Yes, so this is done. Now you can see my I start from here, okay, from 45, and my J start from the 30. So now my minimum is, okay, right? Next smallest element, if you see, right, when you scan it, okay, right, the same thing we're going to do. So I will take minimum to be the 45, okay, and then we'll compare with 30. So 30 will be the minimum, so my position will be 3. Then I will compare, then 16 is the minimum, then the position will be 4. It will continue till you are 31. Then I will go and I will find out the minimum position is 7, which is in position number 6, correct? Okay, so I will swap it, correct? Next again I will do, so I consider now 30 to be the minimum. Yes, now I will start comparing it. Okay, can you tell me which one is the minimum? Yes, 16 is, right? So I got the next element to be 16, right? Then I will swap with 30. Great. Okay, now my I will be going, and now my minimum is 30, right? Now I'll start comparing 30 with 31, no. 30 with 45, no. 30 with 23, yes, my now minimum is 23. Again I can swap, so I will get swapped out here. Yes, right. Next I go for 31. Yes, 31 is the minimum considered. 31, 45, 31 is the minimum. Then I state 31 and 30. 30 is minimum, so I got at position number 7. So again I swap. Okay, so now my I is 45, J is 31. Yes, my minimum position is 31. Then I swapped it. Great, and I got the sorted array. So I got the sorted array as 2, 7, 16, 23, 30, 41, 45. So what exactly we have done is that, I'm repeating again, is that I consider the first element to be the minimum, okay, and then from the next elements I started, comparing it. Wherever I find the minimum, I take the position. So once a complete scan is over, okay, then I swap with the first element, because I'm talking the smallest element. I'm going for an ascending order, right? Then I shift to the next element. So the I start from the next element, right? Again J will start from the next of I. Again we start comparing, okay, and then again we find out the minimum, element. Then I take the position. Then again we swapped it. So that is how we do the selection sort. So the name itself is that we are selecting, right? Yeah, here since we are doing an ascending, we are selecting the minimum. If you want to do the descending order, you have to find the maximum, right? So if you see here, okay, so that's how the entire things we have done. Find another thing is the find the biggest, and you can move to the last. Another way we can do, we find the biggest element, like we are finding out the 45 and placing it at the end. Here you see, here we are adding it for. Then we find out the biggest element, which is 31, so I place it here. Then I find the biggest element to be 30, I place it here. Okay, next I find the biggest element to be 23, I swapped it here. Okay, then I found the biggest element to be 16, plus the biggest element is now 7, and I found it one, right? Okay, so this way, right, what I am actually finding out either the smallest or the biggest element. Okay, if I is smallest, I'm putting it here. If it is biggest, I'm putting it at the last. Okay, so this is how the algorithm goes. So you have seen, right, for I equal to 1 to n minus 1, that you have seen for the first element. Okay, right, then we don't go to the last element. Okay, last element. Okay, then we set minimum equal to I. Then we start from I plus 1, that you have seen, right? We have done that. Okay, let me again go back. If you see, this is, if this is J here, I here, okay, yes, in position 5, J start from 6, I plus 1, correct? Yes. Okay, so now we compare. If it is less, then we set the minimum to be equal to J, right? Okay, and if I is not equal to minimum, because sometimes if I find that this itself is the minimum, Okay, if it's in the middle, then we don't have to do the swapping. If we have to do the swapping. So for example, if I start if the element is a 2, 16, 9, okay, and suppose 10. So 2 is the smallest, right? So once we find out that there is the smallest element is the 2 itself, that is in the I, okay, then we don't have to do the swapping. So that's what the the entire pseudocode itself for the selection sort. Okay, so now so this particular selection sort is actually happen when we have requires an n number of right operations, okay, right? And also it is good for smaller arrays, maybe 10 to 20, like the same you have to bubble sort. But one of the advantage of bubble sort is that I told you that if you have an element in the sorted form, then again we can modify the bubble sort, okay, and then we can do do easily the sorting algorithm, because we can simply bypass the path that you have seen in the video of modified bubble sort. If you have not seen, I will request you to go through that. So wherever you have wherever you require right operation, is useful, okay, extremely it's useful. Whenever you require an n number of right operation, we can go for the selection sort itself. So having said that, selection sort itself is a technique which applies the brute force, okay. It is as simple as bubble sort. As the name, we are selecting the smallest or the largest element, and we actually get the the position of that largest and smallest element. Then we either, based on whether it is an ascending or it is descending, we put the element either in the beginning or in the end of the array itself, or the list itself, right? So that's what the entire selection sort. In my next session, I will be talking about how we are implementing this selection sort using in the C program. Thank you so much. Do keep watching my videos, and do share and subscribe. Thank you.